Okay guys, let's look at how we graph a rational function. So we do the same thing we did for finding the values of horizontal and vertical asymptotes, and then we use those. We also need to find the intercepts, both x and y, ideally. And then ideally from there we can create a test chart to help us, kind of like we did with the polynomials. So let's start by, it says first fully factor the numerator and denominator. And number one, they're already factored. Find the vertical asymptotes by setting the denominator equal to 0. X plus 1 equals 0, which means x equals -1. This is represented by a dotted line. So what does that mean? It means that if I find x equals -1, which is a vertical line, I make a dotted line on my graph going down at x equals -1 to create an asymptote. This is not part of the graph. This is a guideline which will help us make the rest of the graph. I know it's kind of hard to see on there, but there's x equals -1. Our horizontal asymptote, again, the leading power of x, y equals 0x over x, which is just 0. At y equals 0, we do the same thing. Now y equals lines are horizontal. This one's going to be on top of the axis, so it's going to be extra hard to see, but it is there. I label them just so we know where they are. Now the intercepts. You get the y-intercept by plugging in 0. So f of 0 equals 2 over 0 plus 1, which is 2 over 1, or 2. So we plugged in 0, got 2. So this is actually part of our graph, 0, 2. So I'm going to plot it on the graph. The x-intercepts. You have to ask yourself, what makes a fraction 0? Dividing by 0 we know makes the asymptote. It's actually when the numerator is equal to 0. So you ask yourself, when is 2 equal to 0? Never. So there are no x-intercepts. There's no y values of 0 because the numerator is never equal to 0, and 2 divided by something is never equal to 0. Okay, so what do we know? In the polynomials, it was all of your x-intercepts which created our little breakpoints for whether we could cross 0 or not. Now there's an additional place. The other area we could cross 0 is the asymptote, the x equals asymptote, because you could go from -infinity to +infinity as a concept. So my suggestion is when we make our test chart, we need to include all x-intercepts, which we don't have in this case, and all vertical asymptotes, which is x equals -1. So I just need to test values on either side. 0 is a number bigger than -1, while -2 is a number smaller. Good news is we already plugged in 0 for our y-intercept. So we already got the point. We already got that this was positive. It was the point 0, 2. So we need to plug in a point on the left. Now what does this tell us on the right side? That means all the numbers on the right side of the asymptote are positive. So they're above 0. Now we know that as I go towards the vertical asymptote, I either have to be going way up or way down. Since I can't cross 0, I have to go way up. So this kind of gives us the idea that this must go up towards the asymptote. Furthermore, on the outsides of the function, I'm not supposed to cross the horizontal asymptote. So generally speaking, that means this needs to be going way to the right if we're graphing. Now I need to check what's happening on the left side though. So let's plug in -2. That would be 2 over -2 plus 1, which is 2 over -1 or -2. So we have the point -2, -2. It's a negative number for our graph. If I plot -2, -2, it's down here. That means all of my numbers to the left of the asymptote are negative, which means if I'm going either up or down towards the asymptote on the left side, I have to be going down because I can't cross. There are no zeros. And again, I have to be leveling off towards 0 going to the left side. And we know it can't cross the asymptote and then come back down towards 0 because there, again, would be another 0 in that case. So this is the basic look of a rational function. It looks kind of like that 1 over x we started with, only a slight difference there. Let's look at another one that's going to be a little bit more difficult. Graph 2x squared over x squared minus 4. Same strategy though. We start by doing the vertical asymptotes. I say we should factor everything. X squared minus 4 is the perfect difference of squares, so it's x plus 2 and x minus 2. What are my vertical asymptotes? It's x plus 2 equals 0. X minus 2 equals 0, so either x is negative 2 or x equals 2. So here is a case where we have two vertical asymptotes, one at negative 2 and one at 2. So we draw our vertical asymptotes at both places. These also represent domain restrictions. Things your x values cannot be, because again, we can't divide by 0. Vertical asymptote is done. Horizontal asymptote coming next. We look at the leading power of x, which is x squared. Both of them have an x squared, so we have y equals 2x squared over x squared. The x squareds cancel, so this is just y equals 2 as the horizontal asymptote. So we go to where y is 2, and we create a horizontal asymptote. Now we do the intercepts. The y-intercept, we plug in 0 for x. Half of 0 equals 2 times 0 squared over 0 squared minus 4. That's 0 over negative 4, which is 0. So we've got 0, 0, which is going to be one of our x-intercepts as well. That's right here on the graph. X-intercepts, we set the numerator equal to 0. When is 2x squared equal to 0? When x squared equals 0, so that means x has to be 0. So that's that same point, 0, 0. There's nothing extra to graph. Now, to make our test chart, though, every point or a vertical asymptote or x-intercept has to be included in the test chart, which means we've got negative 2, 0, and 2. We have to test points around them if we want to see if they're positive or negative. Now, we don't have to... Okay, let's just plug in points. We've got negative 3, negative 1, 1, and 3. And actually, we'll continue graphing this in the next video.